Good morning, students. I'm myself, Vijay Shankar from C Department, Civil Engineering College. Today, we are going to discuss about some more examples in convolution and correlation. In yesterday's class, we discussed about the examples in the convolution, graphical representation method, in the continuous and the discrete time functions. This is some more examples in the convolution and the correlation in this class. So to find the convolution of the x of t is equal to mu of t plus 1 and the h of t is equal to mu of t minus 2. Okay. Now I'll explain here the x of t is equal to mu of t plus 1. First of all, you can draw the graphical representation of the mu of t plus 1. And another one is mu of t minus 3. Nothing but the h of t is given. Mu of t minus 2. T minus 2. Let us see here. Given function, the x of t is equal to, example, x of t is equal to mu of t plus 1 and h of t is equal to mu of t minus 2. Now you can draw the graph of mu of t plus 1. T plus 1 means start from the minus 1. Its amplitude is a 1. Mu of t plus 1. And you can draw the graph of the h of t. Mu of t minus 2. The h of t is equal to mu of minus 2. So means towards the right side moves the two samples. Here is the magnitude is a 1. But keep the h of t is same, or otherwise keep the x of t is a fixed value. You can move this by the formula saying that is y of t is equal to integral minus infinite to infinite x of t or x of tau h of t minus tau theta. Okay. Now when the t is equal to 0, at t is equal to 0, the y of 0 is equal to integral minus infinite to infinite x of tau. H of 0 means is a 0 minus of tau, so h of minus tau. So folded function of the h of t. Folded function of the h of t is folded at the 0. At the 0 means you will get h value as h of minus t or the minus tau. The variable here, the t is a variable. I take the dummy variable as a tau. So from minus 2 to the value. So folded function. Okay. Now you can see there is no any overlapping of this. It starts from the minus infinite to minus 2. And here the x of t starts from the minus 1 to the infinite. So y of 0 is equal to 0. Y of 0 is equal to 0. Now at t is equal to 1. T is equal to 1. What is the y of 1 is? Integral minus infinite to infinite x of tau h of 1 minus tau. H of 1 minus tau means the integral minus infinite to infinite x of tau into h of, you can take the minus as a common, tau minus 1. One sample here, so to move towards the right side of h of minus 2. Now it is a minus 2 and now it is a minus 1. The value of h of minus 1. So at the minus 1, the x of t is a 1 and x the minus 1, the h of, how to see here, h of minus of tau minus 1. Okay, the variable tau. Both the variables of 1 means y of 1 is equal to 1. Y of 1 is equal to 1 off. At -1 the value. Got it, my students? Now again the t is equal to 2. T is equal to 2. The y of 2 is equal to the integral minus infinite to infinite x of tau h of minus of tau minus 2 d tau. The integral minus infinite to infinite. The x of tau, the value is the same. It is from the minus. Now it becomes up to the value of the 0. So here the -1 to the 0 and here the -1 to the, start from the minus infinite to the minus. So overlapping occurs from -1 to the 0. So change these limitations as integral -1 to the 0. The value is 1 and its magnitude is also 1 into d theta. Previously also, it's a value at x is equal to 1 ohm. Okay, at x is equal -1, not the at tau is equal to -1. At tau is equal to -1, both the values is 1. 1 into 1 all will get. So 1 into 1 the d tau. So tau with upper limit is 0 and lower limit is a -1. So again the value is minus of -1 is a 1. The y of 2 is also 1. Y of 2 is also 1. Similarly, you can shift towards the right side of h of minus of tau minus 2 we got here. Tau minus 3. Tau minus 3 means t is equal to 3. Y of 3 is equal to integral d tau. So both are the magnitudes is 1 only. But it starts from the -1 to the value is now the 1. -1 to 1. -1 to 1. Upper limit is 1 and lower limit is a -1. Tau 1 minus of -1 plus 1 is a 2. So y of 3 is equal to 2. Similarly, at y of 4, at t is equal to 4, y of 4 is equal to, the limitations is now from 1 the 2. So -1 to the 2, -1 to the 2, and so on. Still it is an infinite value, -1 to the infinite also you get 1 into d tau. Again, the value is y of 4 is equal to 2 minus of minus is the 3. So goes on increasing the value 0, 1, 1, 2, 3, and so on. Increase the values. Still, you can move that towards the right side. Got it, my students? Now you can see that at 0, the value is 1, 2, 3, 4, and so on. Goes on increasing the value. Got it, my students? So 0, 1, 2, 3, and so on. It's a ramp function from the 1. At t is equal to 0, there is no any overlapping. What we got is the same. There is no any overlapping. First one. Overlapping means it is a 0 there. At t is equal to 0, it is at the -2 and -3. Here also 0. And still it is a y of 1 is also the 0 because it is only from the -1 and the -1. Still there is no any overlapping here. So you can keep these also, the value is 0 1. Sorry. The value is also 0. So y of 2 is equal to 1, 3 is equal to 2, 4 is equal to 3, and so on. A ramp function. We get at 0 the 0, and 1 is also 0, 2 is a 1, and 3 is 2, 4 is 3, and so on. Now the graphic is you get the ramp function. Okay, my students. Okay. And y of t is equal to 0 for t less than or equal to 0, and y of t is equal to t minus 1 for t is greater than the 0. Means at t is equal to 1, 1 minus 1 is a 0. At t is equal to 2, 2 minus 1 is a 1. Okay, 1 values decreases. The next value, find the convolution of x of t and the h of t. X of t is given from 0 to 2, the magnitude is a 1, and h of t is 0 to 3, the magnitude is a 1. So x of t, keep the value is fixed, and the h of t is only can shift. The first value is a folded function. Folded function minus 1, 3 to the 0, because it is a 0 to 3. Now it is a minus 3 to the 0. So still there is no any overlapping here. 3 to 0. Moves towards the right side when the t is equal to minus 1. Okay. And towards the right side with x of t is from 0 to 2. Now it is shifted from minus 2 to the 1. The first one, there is no any overlapping. T is equal to minus 1 and t is equal to 0 and t is equal to 1. There is an overlapping at this. T is equal to 1. There is an overlapping at this here. Moves towards the right side from minus 2 to the minus 1. Minus 2 to the minus 1. So the 0 to 1 with the integral value is 1, the value is 1. 0 to 2, the value is 2. 0 to 3, the value is 3. And after the 3, there is no any value. Previously, it is continuous 3. And after the 2, there is no any value. The 3 value is 2 and the 4 value is also the 1. And at 5, there is no any overlapping of this. Got it, my students? I will explain here. The x of t is equal to 0 to t and x of h of t is 0 to 3. X of t 0 to 2, that is the x of tau we can consider as a tau variable, and h of t given 0 to 3. Now this is also I am taking as a dummy variable of h of tau, the tau variable 0 to 3. In the first step, at t is equal to 0, t is equal to 0, there is a folded function of h of minus 1 minus tau, h of minus tau. It starts from the 3 and the 0 down to 3, minus 3 and the 0. So compare these two, it is start from the 0 to 2 and the 3 to 3. There is no overlapping. So at y of 0 is the value is 0. Then at t is equal to 1, the graph is moved towards the right side. Graph is moved towards the right side as from minus 2 to the 1. 2 to the 1. So the overlapping occurs here. It is 0 and 1. Overlapping occurs at this 0 and 1 because the x of tau is also saved there. So y of 1 is equal to, here the value is 1 and the 1, integral 0 to 1, 1 with a d term. So the value is a 1. Y of 1 is equal to 1. Okay. Again, at t is equal to 2, still it is further moves towards the right side, means minus 1 it starts, and till up to it gets minus 3 to the minus 1, minus 2, minus 2 to the minus 1, 0 will becomes a 1, and 0 is 1, it becomes a 2 here. So overlapping occurs from the 0 to t, 0 to 2, or the t is for h of minus of tau minus 1 is a h of minus of tau minus 2. So y of 2 is equal to integral 0 to t 2 d tau. So the value is a 2. So y of 2 is equal to 2. Still at the t is equal to 3, it moves from minus 1 to the 0 here, and the 0 the value is a 3. You get like this. It's the same as h of tau now. H of minus of tau minus 3. After the 3 samples, it is again we get the same fraction. Now the overlapping occurs only at the 0 to 2 only. Okay. Again the same value, y of 3 is also 2. And t is equal to 4. Still it is moved from 0 to 1 here. 1 to the last value is a 4. Now the overlapping is from 0 to 2 here, 1 to 2 only. 1 to 2, the overlapping occurs is a h of minus of tau minus 4. Got it, my students? Tau minus 4. So ht is equal to 4. The value of y of 4 is equal to, the limitations is from 1 to 2 d tau to 2 minus 1. So the value is 1. Y of 4 is equal to 1. Still again the t is equal to 5. It moves towards the right side. So now the 1 is returned from the 2 to 5. Now there is no any overlapping occurs. So the y of 5 is equal to 0. So what is the values here? The y of 0 is a 0. Y of 0 is a 0. Y of 1 is a 1. 1 is 1. And 2 is 2. 3 is also 2. 3 is also 2 minus 4. So now it is like this. And constant at 2, 3. And y of 4, the value is decreases to the 1. And at 5 is a 0. Okay, the graph is increases 0 to 3 and constant at 2 to 3. And decreases from the 3 to 5. The y of tau or y of t is equal to. Got it, my students? See, from 0 to 2, it increases. 2 to 3, the constant, and 3 to 4, 5, it is a, again, it is a decreases. Okay. Now, another example, find the linear convolution of x of n is equal to, linear convolution x of n is equal to 1, 0, 5, and h of n is equal to 1. Constant of h value, x value, the x you can draw the graph at n is, there is no any arrow mark with the first value is a 1 or 0, value is 1, x of n, and at the 1, 0, and it's not the 0, so I think a 0.5 minus 1 is a 0.5. There is no any third value, only the two values. H of n is given. H of n value 1 or it is 0. The two values in x and one value is the h. How many values will get for the y after the convolution of these two functions? 2 plus 1 is a 3, 3 minus 1 is a 2 functions. So at two values will get the y of n. H of n. So first of all, it is a folded the function. At the 0, there is no any change the folded function. The 0 only. So 1 into 1. The y of 0 is a 1. Y of 0 is a 1 here. And next one is y of, after the folded function also, h of minus tau is the same, 0 to 1. So at the 0 here the value is 1, here the value is 1, 1 into 1 is a 1. Next is a shifted version, h of minus of tau minus 1. One value is shifted towards the right side. Now the 0 is a 0, 0.5 into 1 is a 0.5. 0.5. Still it is moved towards the right side. H of minus tau minus 2 means 0 is a 0, 1 is also 0, 2 is also 2 is 1 now. Now there is no any value of 2. Both the functions is a 0. The y of 2 is 0. Still you can move, the value will get the same. Whatever the function here, the x of n with the convolution with the h of n with the single value, same value, the y of n is equal to x of n only we got. 0, 1, and the 1 value is a 0.5. So y of t is equal. Got it, my students? It is the impulse response convolute with any signal, you get the same signal. And now, take one example here. Perform the linear convolution of x of n given the 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, h of n is equal to minus 1 to 1. Need to find the y of n. How many number of samples will you get for the y of n? 2, 4, 6, 8. 8 plus 2, 10, 10 minus 1 is a 9 samples will get because the formula is a m plus n minus 1. 9 samples you have to find out. Okay, what you have to do? Only the shifting occurs in the h values. The given h value, the given in the h, 0 is minus 1 and 1 is 1. H of tau is equal. H of minus tau, the folded function. H of minus tau is a folded function. Minus 1 is a 1 and 0 is a minus 1. Okay, the tau is equal. So here there is no any minus 1 value of x. Only at the 0, there is a value is 1. 1 into minus 1 means y of 0 is equal to 1 into minus 1 is a minus 1. So y of 0 is a minus 1. So here you get the minus 1. Next, you can shift this value towards the right side. H of minus of tau minus 1 means one sample is moved. The 0 value is 1 now and 1 value is minus 1. Now multiply at the 0, there is a 1 is there. Y of 1 is equal to here the 1 and here the 1. 1 into 1 plus here is a minus 1 and the minus 1. Minus 1 is a plus 1 is equal to 1 plus 1 is a 2. See the magnitude is a 2. Y of 1 is equal. Okay. Still it is moves towards the right side of 0, not the 0, sorry. The 0 is a 0 here and the 1 is 1, 2 is minus 1. And now you can multiply the whatever the values are there in the 1 and 2. At 1 minus 1, now it is a plus 1. So y of 2 is equal to minus 1 into 1 is a minus 1 plus at 2, the magnitude is a 2 here, 2, and this magnitude is also 2. 4 is a 4, not the 4, minus 3, not the minus 3, is a plus 3, sorry, minus, and this is a 4 and minus 4. The value is 1 and the minus 1. These are the values in the x given. And now 1 and 2 is multiplied. 1 and 2, minus 1 into 1, minus 1 plus 2 into minus 1, that is a minus 2. So you'll get y of 2 is equal to minus 3. So minus 3. Still again, you can move it towards the right side. 0 is 0, 1 is 0. Now the 2 is 1, 2 is 1, and 3 is minus 1. So now you can multiply the 2 and 3. At 2, the x of value is a 2, 2 into 1. Y of 3 is equal to 2 into 1 is a 2. And here the 3 is a 2, 2 minus 1, minus 2. Minus of minus, it becomes of plus. Is the minus. Minus into minus is a plus. 2 plus 2 is a 4. You get the 4 minus 2. Still again, you can move towards the right side. Means 0, 1, 2, all the values is a 0 now. And 3, the value is 1. And 4, the value is minus 1. Minus 1. So you can see the 3 and 4 here. 3 is minus 2. Minus 2 into 1. So y of 4 is equal to minus 2 into 1 plus. At 4, the value is 3. And here the minus 1. 3 into minus 1. So minus 2 minus 3 is minus 5. So y of 4 is minus 5. y of 4 is minus 5. So y of 3 is 4, y of 2 is minus 3. So minus 1, 2, minus 3, 4, and minus 5 equal. Still we can move towards the right side of h value. So it start from the 4 is 1 and 5 is minus 1. 5 is minus 1. So 5 and 4 only can check here. 4 is a 3, 3 into 1, 3. So y of 5 is equal to 3 into 1 is a 3. And 3 at 5 here, the minus 1, there is a minus 1, minus 3 and minus 1 plus 3. You get the 6. Y of 5 is equal to 6. So y of 5 is equal to 6. Still you can move towards the right side. Then you can see the 5 and 6. 5 and 6 because it is moved towards the right side. So at the 5 here, the minus 3, there is a 1. So minus 3 into 1 is a minus 3 plus 4 into, here the 4 is there, it's a magnitude, 4 into minus 1, minus 4. So y of 6 is equal to minus 3 minus 4 is a minus 7. Y of 6 is equal to minus 7. So minus 7. Then still the h of values moves towards the right side from 6 to 7. 6 value is 4 and the 7 value is minus 4. 4 into 1 is a 4 plus minus 1 into minus 4 is a 4. 4 plus 4 is 8. Y of 7 is equal to 8. But it matters to us. And the last value, still it is moved towards the right side. At 7, the value is 1 and the 8 is a minus 1. There is no 8 here. 7 into 1 is a minus 4. 7 into 1 only. The 7 value is a minus 4. Minus 4 into 1. Minus 4 into 1 is a minus 4, my students. Here it's not the minus 4. Okay. Y of 8 is equal to. So it starts from the 0. The value is a minus 4. 1 into minus 4 is a minus 4. Okay. So like that we can find out any given function. Okay. Any given function, either in the continuous time function or discrete time function. We can find out the convolution of the two functions, keeping the one signal x of t signal is a constant, and we can only fold it and shifted the version of h of tau value, because in the formula itself saying that x of tau and h of t minus tau. I am changing the values of t, shifting the value of h of t minus tau towards the left side, first of all folded function. Then after one sample is ahead, moves towards the right side and multiply with the values of x of tau. Got it, my students? Next, another example. The convolution of x of t, given the magnitude is 1 from 0 to 2, and h of t, the magnitude is 2 from minus 2 to the 1. Minus 2 to the 2. So here the 2 is there, minus 1 to the 2. Minus 1 to the 2. Minus 2 to the 2 we can take here. That is, the graph is changes here. The minus 2 it start there and the 2 is here. The x of tau and the h of tau is taken from the minus 1 to the 2 only. At minus 2, y of minus 2. Y of minus 2 is equal to 0 because there is no any overlapping of the folded function here. Of the folded function means 2 minus 2 it starts. This is a folded function, I think. Sorry, this is a value of 1 only, the given function. Its folded function means whatever the positive values are given here, will get in the negative values from minus 1 to the 0. Whatever the negative values here will get in the positive values. So 0, 1, and the 2. Its magnitude is a 2. Its magnitude is a 2. Okay. This is a h of tau. H of minus tau minus 2. It's the folded function. H of minus tau. Now see, from 0 to 2 there, and here the 0 to 2, the value is a 2. Minus 2. 1%. Y of minus 2 you can take. What is the value? Y of t is equal to integral minus infinite to infinite x of t at x of t, x of tau, h of t minus tau theta. Okay. So y of 0, if now I am taking, y of 0 is equal to minus infinite to infinite x of tau, h of t is now the 0 minus tau theta. What is the y of 0? It is a overlapping occurs from 0 to t. Here also the 0 to t. The integral values becomes of 0 to 2. Both the magnitude is a 4 into d tau. 4 into 2 is 8. 4 into 1 only. Okay. X of value is a 1 and its magnitude is a 2. So 1 into 2 is a 2. So 2 into 2 it becomes of 4. So y of 0 is equal to 4. So you got to see here the y of 0 is equal to 4. And y of 1, you can take the y of 1 and still it is a moves towards the right side, 0 to 3. The graph is now towards the right side. It starts from the 0 and the 3. 0, 1, 2, and the 3. Again, here also the overlapping occurs the 0 to the 2 only. So y of 1 is also 4. Still the graph moves towards here. 0 it start and from 1 to 4. 1, 2, 3 and the 4. So the limitations now the overlapping is only from 0 to 1 to 2. The y of 2 is equal to 1 to 2, 2 d tau. So 2 minus 1. 2 minus 1 is a 2. The value is a 2. So y of 2 is equal to 2. Y of 2 is equal to 2. Okay. Next, still you can move that the value 0, 1, 2 means it starts from the 2 to 5, 3, 4. There is no any overlapping. So the y of 3 is equal to 0. Y of 3 is equal to 0. Still you can further can move also. There is no any value you get. Now I am taking the h of minus of tau plus 1. Means minus of minus 1 is a plus. So move towards the right side, left side, sorry. Minus 2 and this becomes of 1 here. Minus 2 to the 1. So 0 to 1. So overlapping occurs from the 0 to 1. So y of 4 is equal to minus 4 is equal to, y of minus 1 is equal to, sorry. Y of minus 1 is equal to integral 0 to 1, 2 into d tau. That is equal to 2. And y of minus 2 is equal to, you can move this towards the left side. Now overlapping, there is no any overlapping because it starts from the 0 only, minus 3 to 0. So y of minus 2 is equal to 0. Okay. So y of minus 2, 0. So now we can write the equations sequence. Y of t is equal to, we got the values from 0 is 4, minus 1 is a 2, and minus 2 is a 0. And this is a value at the 2, 0. And again the 4, 2, 0, 3 is a 0. So 2, 4, 4, 2, the value is a 1. See, at minus 2 is a minus 2 value. Minus 2 is 0, minus 1 is a 2. The value is a 2. And 0, the value is a 4. And 1 value is also 4 because it's a constant. And a t is equal to 2, that is a value is a 2. And t is equal to 3, the value is a 3. It goes on increasing and it's a constant and it is a decreases. Got it, my dear students? Now the properties of the convolution. Properties of convolution. One is the commutative property, we know the distributive property and associative property. Commutative property, distributive property and associative property. All it is a obeys, commutative properties obeys and distributive properties obeys and also the associative properties also obeys. Got it, my students? Remaining properties we have already discussed in this again. That the remaining properties are shift property, convolution with impulse, convolution with shifted impulse, convolution with step function. See, in the previous examples also we seen one example, the convolution with any impulse signal means the same signal with x of t with the convolution of delta of t is x of t. X of t with the convolution of the shifted version means at whatever the value is shifted, the values only will get x of t minus t. Here t delta of t is a t means x of t. Delta of t minus t naught means the x only will get, but a t minus t naught shifted one. Convolution with the step function. Convolution with the step function, you get mu of t minus 1 is equal to 1 for the tau is less than the t is equal to. Okay, 0 to actually from mu of t means mu of t is equal to 1 from 0 to t, 0 to infinite. Here it is a shifted version, the mu of t minus tau. So the values is from t minus tau is equal to 1 and tau is less than the t. Tau is less than the t means the limitations is from minus infinite to the t value. Got it, madam? So these are the shifted value properties of the convolution. Commutative property of base, distributive properties of base, associative properties of base, and shifted property means x1 of t and x2 of t minus t. Output is also the t minus t on. Similarly, x1 is also shifted, the output z is also shifted. If both are the shifted with the t1 samples and the t2 samples, it is shifted with the sum of those two shifted samples minus of t1 plus t2. What it matters?